Okay. I think I finally have it. I was really struggling. I don't know. Stuff kept crashing on my computer. I had to restart it. So anyway, tonight I really need to do homework. I have my assignment due tomorrow. And I figured, hey, I'd stream. Why not? So hopefully this can go well and I can get some work done and maybe people will find some of the things I'm doing interesting. I'll probably just, speak my thoughts while I'm working on this. You're welcome to interact or not, whatever you choose. Anyway, might as well get started. Real quick summary of what this homework is about. Basically, given two images viewed from a different angle, kind of like how your eyes view from a different angle. You determined where the camera is in 3D space, and then you can reconstruct basically those points. So this is the results my professor gave, and I'm effectively going to have to reconstruct that. The images that we've obtained previously to do this. Right now I'm doing the sparse reconstruction, and effectively the image looks like this. And then the next image is like that. And so from those two images, I figure out where the cameras for each image is in space, create a sparse point feature matching, I guess. And yeah. So what I've done so far, loaded images, obviously, got the feature matching, points from feature matches. I've done stereo rectification, which I believe is about creating the epipolar lines, which if you don't know what those epipolar lines are, that's what these red lines are here. I could go into a really complex description about how the epipolar lines are effectively a plane in 3D space that map a point to a, like, you see a point here and you see a point here and you say, oh, those are the same point. You map that in 3D space, and then the line is the plane. If you create a triangle from the point in the picture and the point in this picture and then the point in 3D space, create a triangle that each line is that plane. And so these top two here is the plane from the camera's perspective, and then the bottom two is each image transformed such that the plane is completely horizontal, to kind of basically match it on a horizontal plane length. Anyways, the next step I'm supposed to perform is, well, I'll figure that out. I think I'm supposed to, he's wanting me to print out several matrices here, and this is his sample output. That's not mine. So basically, I need to find the fundamental matrix, which I think I already have from here when I get the epipolar lines. I need the intrinsic matrix, which is, I actually don't know what the intrinsic matrix is. So now I'm going to stare at his instructions, and what I normally do is I actually get AI help, so. Whatever you feel is necessary. Alright, I'm going to assume the intrinsic matrix is, oh boy. So perform triangulation. I think that's what I was in the middle of right now, right? Yeah, I was trying to figure this out. Perform triangulation, I have to write a function. Returns a 3D point when provided the input. What the fudge? What did YouTube take us to? Oh, Halo? Ha! Whatever. It's not entirely what I wanted in terms of music. I was hoping for something a little more chill. So let's just go to... Like, I was really craving the end of the world, which is why we started with that, but I don't want it anymore. So... I would prefer just to do... We're gonna go Zelda, because I don't really want Halo. We'll just deal with Zelda for now. Why are you not playing? Alright, back to triangulation. Input is... So, my wife got upset because I left my phone upstairs and she was trying to contact me to send me a TikTok of a coffee maker. She's really into coffee lately. So that was fun. Sorry about that. Anyways. So this was basically AI generated, but I don't know that it's what I want. I admit, I don't really know what I'm doing until I do it. Like, I understand what was taught in the class. I get that. I get the logic behind that, but, like, I don't know what an intrinsic matrix is. We didn't really go over those kind of things. An essential matrix, I think I get the projection matrix. I think I got that. But these matrices here, I'm not positive on. So anyway. Computes and returns the 3D points when provided with the input. The input being two projection matrices, which is what's here. So I have the projection matrices. Makes sense. And two sets of corresponding key point matches. Which is what this is. That makes sense. Because if you go up here, points 1 and 2... What is points 1 and 2? They are lines. Maybe that's not what I need. Those are the epipolar lines. Okay, so my professor gave us a whole bunch of different, basically almost all the methods we'd need to use. So I've kind of been reverse engineering this. Hmm. K1 and K2. I know, the comment is the instruction. So I think points 1 and 2 are actually KP1 and KP2. I feel like that's it. I don't think they're the lines. I think they're KP1 and KP2. Just for my sanity. And then, if I understand the key point dot T correctly, see, there's a dot PT. Oh gosh. Okay, I need an explanation of CV2 dot triangulate points. I think that's gonna help. So the projection matrices and the projection points, obviously. But yeah, it's the feature matching. That's what this is. This is the feature matching. Which are the key Oh, so it's the okay. I got this. So it's not the key points. It is points 1 and points 2. And I don't think it's dot T. I think it's just literally the points. And honestly, I think we just return points dot 40. I don't understand why it uses 4D. Like, it named it, I didn't name it, but these are points in 3D space, not 4-dimensional points, but whatever. Okay, so that basically solves that. And we'll have lots of debugging to do later. So now we're here. Calculate the essential matrix E using the fundamental matrix F, which we have, and the provided camera intrinsic matrices K1 and K2. But I don't think I have K1 and K2. Do I? I don't. How do I get the intrinsic matrix? Compute the projection matrix. But don't I already have the projection matrices? I'm so confused. maybe I don't. These steps are not in order. So this is my main algorithm block. For images. So the fundamental matrix is here, obviously. The matching points are here. So all I have at this point is the fundamental matrix. I do not have the projection matrix. So how do I get the projection matrix? Oh no, I'm computing that here. I'm computing the projection matrix here. How do I get the intrinsic matrix? I'm so confused. We need to compute the projection matrix given the fundamental matrix, which I have, and the intrinsic matrices, which I do not have. Does it give me anything to get the... What does SVD do? Is that the intrinsic matrix? Like, I remember learning SVD, but... Okay, so let's start with this. Hopefully it understands that I'm still in the context of Python. Okay, let's try this. So we read the images. Convert each image to grayscale. Get the corners. That seems really complicated compared to what I've already been doing. Wow. Alright, I'll be right back. I need to run a quick errand for my wife. Alright, I'm back. I feel like this section is a blocker for me. I don't really know what I'm doing. I have a hard time believing. A lot of what we've done so far, it's fairly quick. It's fairly limited. And so I'm just supposed to do this complicated mathematical thing to get the intrinsic matrix. Blah! The intrinsic matrix. That just seems strange. Maybe it's calibrate camera. Maybe that's what I need. It has to be the most confusing assignment we've had so far. Object points is a list of 3D points in the world coordinate system, so we have that. Image points is a list of 2D points from the image plane corresponding to the 3D object points. So those are camera points. Image size, we have that. Camera matrices. Is it matrix? But we don't have that, remember? We have object points, we have image points. I don't know what gray dot shape is. Oh, it's probably the image size, actually. Okay. Okay, I think all we really need is this call. We'll give that a shot. So we can do cv2.calibrate camera, so we'll do... we'll have to do it for both. So we need 3D image, or 3D points. Doesn't like having a number in the beginning. 3 points 3D. Points 3D, points 1. Points 2, and then, what, image shape? A1 equals 2 dot. I think it's calibrate camera, right? You know what? My freaking naming conventions all over the place right now. And then we need the image shape, which we are assuming is going to be the same for both. Right, and we have none. I forgot about that. See, that's much more what I would expect. Just one call to build upon the work we've already done. That gives us the intrinsic matrix. So we have F, K1, K2. And now we need the essential and two projection matrices. Yeah. Okay. I think calculate the essential matrix using the fundamental matrix and the provided intrinsic matrices. We have those now. So we can get P1 and P2. No, we're getting the essential matrix. Okay, so just this one then? Probably with find essential matrix, so that makes it easy. Okay. So we'll just grab this as our comment. And supposedly we use the fundamental matrix and the two intrinsic matrices. And then it's probably CV2 dot V2. Oh my goodness. Something essential matrix. You know, AIs used to help me and now it's not doing anything. Alright. GPT is just so much easier than Googling. I knew it was OpenCV. I just freaking knew it. Points 1 and points 2. So we still need to provide points. We need to provide the intrinsic matrices. Distortion coefficients? Done that, done that. Find essential matrix. Points 1, points 2, intrinsic matrix 1. Matrix 2. What about the essential? I'm so confused. Or what about the fundamental matrix? We have the fundamental matrix. I don't feel like we need the diff coefficient. you guys hearing the draft in my fan? Because if you are, I need to go shut. You know what? I'll just go shut off the fan while I think about this. Is there a step I'm missing? Perhaps the fundamental matrix is used to get... Okay, so how does the AI get the distance coefficient? We get matches. We already know that. We've already done all that. Got the match points. We already have all that. We got the where's the... Where is distance coefficient 1? Like, that's not in the AI sample code. The distortion coefficients of the two cameras. And their corresponding camera matrices and distortion. I don't have the distortion. Do I? I mean, I did the... Hold on. When we did the rectification, we just did warp perspective. H1 and H2. Those are probably the distortion matrices it's talking about. But then, what is the point of the fundamental matrix? So this method doesn't use the fundamental matrix at all if you already have H1 and H2. What I'm getting. I feel like I'm guessing though, like... Here. I have a question for the AI. Hopefully this will clarify things. Calibrate camera, already did that. That gives me the intrinsic ones. Compute the fundamental matrix, I've already done that. And then what? You just use the formula? Okay, but what is T? So it's basically what is K dot T? This, I mean, K, I'm assuming is just a numpy array. Okay, hold on. Let's try this. That makes 0. But thank you. It's a tuple. This is why I need a debugger. Seriously. This drives me insane. Working in Colab just drives me up the wall. Because I cannot see the data types. I do not know what K2 is. Is this an indie array? Is it a tuple? I haven't got a freaking clue. And it drives me up the wall. Which is why I normally pull out freaking PyCharm, copy all the code to PyCharm, and run it that way. This just says K.T. What is T? At F at K. This doesn't make sense because these are matrix multiplications. Not, I don't know why there's an at sign. This code makes 0 sense. So, I mean, theoretically here, we can be like... So K raised to the teeth power? Like... Is K.T even... It just doesn't make... Like, if I use this code, if I'm like, oh, let me just use this code. Let me copy paste this code. That doesn't make sense. I could be like, oh, K1 and K2 or something like that. Like, but this, it doesn't make sense. What is the at parameter? What does at even do? Okay, here's a question. Let's ask Gemini. What does at do? Python. Matrix multiplication. That makes sense. But what is the... Okay, so... What is the T parameter in a matrix such as A1 dot? The transpose of the matrix. Okay, how do you get the transpose in Python? I'm just really annoyed. So it's a literal operator. You could also do matrix dot transpose. So this is legit code. Okay. The only mistake was the tick mark. If we go back up here, make sure I'm not insane. So, we have the essential matrix. Now we need to compute the projection matrices. I'm going a little nuts here. Why is this labeled extra? Alright, let's just read this through and not... Extra 1 is the rotation, which is R1. Equals identity. Gosh, stop, go away. Translation T1 equals 0. Use extra 1 and A1 to obtain the projection matrix of the first camera. Use the essential matrix to predict the extrinsic matrix of the second camera. So that's what this is, the extrinsic matrix. There will be 4 estimates, of which the one for which most of the projected 3D points are in front of both cameras. Use this extrinsic matrix to obtain the projection matrix of the second camera. Wasn't I told that this theoretically could also give us the extrinsic matrix? Alright, well, that's a mistake. I assume. Of course, for the sake of consistency, still making this K1 and K2. Didn't I ask for the return values of calibrate camera? There it is. That's the intrinsic distance coefficients. So that actually gives me distance coefficients. Okay, so you don't actually get the extrinsic matrix from calibrate camera. Fine, that's not a problem. And all we really want to keep is K1 and K2, because this simple equation with the fundamental matrix can give us the essential matrix. So from our output, we have F, K1, K2, E, and now we just need the last two, E1 and B2. And then we're done with half the homework. I'm gonna be up late. Calculate the essential matrix. We already did that. Compute the projection matrices as follows. I don't understand this supposed equation. Extra 1 arrow rotation equals identity. This doesn't make sense to me. That's half the reason why I'm going to AI, because it's like, oh, what does that mean? Interestingly enough, I haven't used SVD at all so far. So I think what I want to know ultimately is how to get the extrinsic matrix. This time I'm going to enforce the Python context for Gemini because I feel like it hasn't been working. Blah, blah, blah. More calibration. Well, that doesn't help, like, at all. Okay, so, well, hold on. R, the rotation, cv2.rodriguez are vectors, which you don't want to use that. Okay, so I have the essential matrix, the fundamental matrix, and the intrinsic matrix. Okay, so let's try this. Let's try I have fundamental. Gotta be specific. Given F, E, and K for 2 cameras, which I do have. But recover relative rotation and translation from the essential matrix, which is exactly what I was trying to be told. This music's a little loud, so we'll turn it down. Exactly what the comments from my professor was trying to tell me. To decompose the essential matrix E into a rotation matrix and a translation matrix. And then you just H stack them. That's easy. But I don't have dist coefficients. I have the essential matrix, points 1 and 2, A, but I don't have the distance coefficient. Is that going to be a problem? Maybe I should keep them. I'm throwing them away. Maybe I shouldn't. Sure, we'll keep them. Why not? So we do a recover pose. I We don't, what we're really looking is for the positional matrix. We need E points 1, points 2, A1, A2. I normally don't like having that much, but here we are. It'll be R1 and T1. Why does it say for the second camera? Like, that doesn't make sense. Because it's saying, blah, 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 blah. If we go up here, the extrinsic matrix, you get the rotation and translation matrix, which gives you the projection matrix. This language does not make sense. There will be 4 estimates, of which the one for which most of the projected 3D points are in front of. That I don't understand that phrasing. Like, this whole thing doesn't. It drives me up the wall. I love it. Not in a bad way. It's just like I don't understand what I'm reading. Projection matrices are 4x4. Or 4x3, or 3x4, sorry. 3x4. Which was an outstanding question if I needed to do this last step of 001. But I will. But yeah, I mean, we'll go ahead and use this. I'm going to have to assume that that's. And don't worry, you think I'm taking the easy way out. Guarantee you I'm going to have a lot to troubleshoot. I want to cry. Doing a lot of coding without verification in between, which is a fundamental problem of Google Colab. Because if I were to run, like, if I were to do these things one at a time or whatever, and run them, there's just no debugging capabilities, really. Not in my opinion, at least. You'll see. Before the end of this night, you'll see me break out PyCharm, copy all this code into PyCharm, and just have at it. It's gonna happen. It's me the extrinsic matrix for first one. Use extrinsic. How do I get the... Okay, so how do I get the projection matrix from the extrinsic matrix? My spelling is awful. So basically, K and then a matrix multiplication. Although it says combine it into 3x4, and isn't this just like... I really need to... I'm gonna get rid of this because I'm gonna assume T1 is not one-dimensional. Or R1, whatever. I'm gonna assume that this creates a 3x4 because that's what this supposedly does. Which makes sense. And then we'll take the intrinsic matrix times the extrinsic to our projection. Alright, so P1 is going to be intrinsic matrix. K1 times EX1. Okay, times at. Theoretically, that should work. And then what? I could probably just do the exact same thing, couldn't I? But the instructions suggest using the essential matrix to get the second one. Alright, that's what I want to do. Let's see what Jim and I can do with this. Let's see what Gemini does with that. Cover relative pose. Obtain 4 possible poses. Rotation matrices R and translation vectors T. Okay, that... Cover best pose. In range 4. What, do it 4 times? I'm so confused. I didn't... I don't understand. Passing I here. Okay, hold on. Let's go to official documentation here. I please get official documentation? I need the documentation for this, please. Alright, so there are, in fact, multiple recover poses. Aspect ratio, I guess, is what it's... No, that's not right. This is a 1, 2, 3, 4, 5, 6. A 6 input 1. 1, 2, 3, 4, 5, 6. 6 right there. That's not right. Double focal right here. This is probably it. Probably what Gemini is using right there. Points 1, points 2, R and T. Points 1, points 2. But that's not what it's not using R and T. It's using K1, K2. I don't understand. This is the version that I used prior. Intrinsic matrix. See that this is wrong. This doesn't make sense. K1 and K2. What exactly is K1 and K2? Let's go with that. Let's figure out what, for some strange reason, what Gemini thinks K1 and K2 are. The intrinsic matrices. Except, according to OpenCV, there isn't a recover pose that has the intrinsic matrices as an input. So this doesn't make sense. And if I could understand phrasing here, I might better understand what I need to do. I don't understand that language. Why can't I just use the same equation that I used to get the first projection matrix in order to get the second projection matrix? In fact, that's what I'm going to do. I don't understand what I'm reading right here. So I'm just going to get the second extrinsic matrix and get the second projection matrix in the exact same way I got the first one. Because this makes sense to me. So, what we'll do. I'm getting hot. I might have to turn on my fan again. All right, one sec. I'll do that. All right. Back to the grind. I really hope this works out. Like, am I breaking something? Should I put points 2 first? I mean, that seems logical, right? If you didn't know, like, if you didn't know the order, you wouldn't know the order. So theoretically, if I just reverse it, it would be as accurate as this was. Except that the essential matrix was calculated. I think I see where the problem is. There is an order. There is a points 1 and points 2 because of the essential matrix. back to the drawing board. And I want to just erase my chat. I want to restart. In Python. All right. Decompose essential matrix. Really? That's a completely different method. We multiply the intrinsic matrix K with the combined rotation and translation matrix to get the final extrinsic matrix. Decompose. Oh my gosh. Oh my freaking god. I've been using... Just breathe, man. Just breathe. I've been using recover pose, but I don't need to do that. I can do this, which gives me the rotation and translation matrices. Okay, but what about... This is saying, which is like completely 90 degrees from what I had before. This is saying that I can get the extrinsic matrix for camera 2 first. And then do a dot product to get the projection matrix. No, that doesn't make sense. That doesn't make sense. I think this more follows... I think this more follows what the professor was saying up here, if I remember correctly, is you get the rotation and translation, and then you can use the okay. I don't understand why translation is 0 though. Rotation is identity out of the essential matrix, and translation is 0. You get the projection matrix. I don't understand this language at all. It's so confusing to me. If we go down to the second half, I worry that all of this is not going to be quick. This is 70 points. Freaking... This whole thing is 80 points. Okay, so this is the harder one. All right, let me... I need to start doing some of this. I need to start running this to understand if I even have it right. I can't do triangulation. I can't run the triangulation because I don't have the projection matrices. But theoretically, I can get, what, the intrinsic matrix? I think I can get the intrinsic matrix, so let's do that. One. Okay, what? I just realized the logical fallacy here. To get the 3D points, I do triangulation. To do triangulation, I need the projection matrices. To get the projection matrices, I have to use the essential matrix, which comes from the intrinsic matrix, which comes from calibrating the camera with the 3D points. And round it goes. Normally these are done in order. Write a function that computes and returns the 3D points when provided with the input, which is 2 projection matrices and 2 sets of corresponding key point matches. So I wrote a function, but I can't use it. I have to first calculate the essential matrix and the intrinsic matrices, which means I need to obtain the intrinsic matrices. So I have to do this without this. Two images as... Come on, Gemini, you're leading me in circles. Why 2 images aren't enough? Where's object P come from? Zeros. I'm so lost. I don't know what I'm doing. I don't understand how to get the intrinsic. Go into the slides, my friends. Great and all. Did the epipolar lines already. Ours is what we're doing. Intrinsic matrices are fixed for a given camera. Find K1 and K2 using traditional camera calibration approach, aka checkerboard pattern. So that's exactly what Gemini has been saying. But I have not been able to figure out how to do that. Their disparity is part 2. Okay, but I don't have E. How do I get E? So this is the 4 solutions he was referring to. I'm gonna have to rewatch this lecture because I don't freaking know what I'm looking at. Like that's great. You can throw the math at me all you want, but how does that translate to code? So we get E from SVD. That's basically what it's saying. Estimate E using the 8-point algorithm SVD. Estimate the epipole SVD of E. I don't know what this is. Oh, epipole. You get the rectangle from E, decompose E to R and T, set R1 equal to rect, And R2 equal to R times back. I think I'm getting too tired for this. Yeah, see, now we're outside of the scope of the actual, or at least of what I'm working on. I might have to bring this to the professor tomorrow. Because I just can't figure it out. I think that's the main blocker too. Is it I don't know how to get to the intrinsic matrix. If I can get the intrinsic matrix, it's not just the intrinsic. It's the intrinsic and projection matrices. I cannot figure them out. I think I'm gonna have to ask him tomorrow. Which is gonna put me down to the wire. We're getting this first part done. I hope the second part doesn't build on the first part. Alright, here's what I'm gonna do. I'm gonna move on to the second part, because if I just say I'm done for the night because I'm stuck on the first part, then I'm gonna have to do all of this tomorrow, plus fix whatever I'm missing up here. So the logical thing for me to do would be to try and erase all that from my mind. Start here. So that's what I'm gonna try to do. Read the calibration file to extract the camera intrinsic matrix, focal length, and baseline. Oh boy. So, sample number 1, we're just going to go to art as our kind of a best example. We want to read the rectified images left and right, one of the dataset folder. Then we read the calibration file and extract the camera intrinsic matrix, which would be, I suppose, this. I really dislike it when I have to waste time parsing a file, and that's not like the point. It's just I'm exhausted and I don't really want to do text parsing. Could have that function already read the 2 images up here. We could probably just do that. What I really need to do is create a function to parse the file effectively. So that's what we'll do. We'll parse the calibration file. Oh, look, Gemini is giving me suggestions finally. Thank you, Gemini. Thank you so flippin' much. Couldn't do that earlier, but you can do that now. No, Gemini, we have to combine the calibration path with the base path. So fine. Why are you complaining about my call? OS is part of the import. Although if it's not... Happy now. Wish there was a quick way to do this. Let me see if I can get AI to make my life easy. Look at that. Same thing here. Bam! This case, my friend, you just need hold on, chill. Should be no second split. Need this. feel like this is going to become ugly. I mean, that's ultimately what this is going to end up being. It's effectively a switch case, which... Does Python do switch cases? Guess not. So we're just going to do a bunch of if, elifs, because reasons. You do know. How do you know? That's so cheating. How do you know this? This is a lie. Oh my god. It's spying into my files. I don't know how I feel about that. Watch this. It's going to be the next one in line too. F? F is not there. We're looking for width, noob. Width. Which BT dubs is an integer? And then if this was a smart AI, it would know, yes, that I'm going for height. Okay. Well, if F is just a placeholder at this point. In DISP. Is it a float? No, I'm gonna go with an int. Seriously, how is there not a switch case? This seems horrible. Like, this is terrible coding. Granted, you have to understand that my carrying is pretty nil right now. Like, we're at 0 craps given. Just throwing that out there. Vmin and Vmax. Is that right? And then once again, because AIs are smart, I'm going to understand that my next one is going to be Vmax. Do it all for me. See? Bam. Smart. Nice when the AIs actually helps, unlike up freaking here. And just this real quick. You believe in miracles? We can read our 2 images. We can now read the calibration file. That gives us basically everything here. Compute the left and right disparity image from the grayscale stereo images. Stereo beam. Pair it with the provided disparity images. You can use stereo BM algorithm from OpenCV. You will need to adjust the two parameters each stereo dataset to obtain the best result. Okay, but how do you programmatically do that? Or is that just a parameter we do manually? I think I'm just going to pass that as a parameter and do it manually. How nice would it be, like, if I finished the second part and the only thing that I was waiting on was basically the place I was stuck? That would be so freaking cool. AI? No. Not gonna be nice to me. Oh, look at that. Yeah. So image left, image right, and disp, which we're given. Are we given block size? Hold on. We're given the end disparity, but we're not given the block size. It says we'll need to adjust this though. I mean, it seems happy. Yeah, I mean, that seems reasonable. We'll have to figure out each one. Later, but that's fine. Although, you've got to wonder. Compute the left and right disparity images from the grayscale stereo images. I don't think this is right. I was expecting 2 results, and I'm getting 1. Understand what each of these is doing. Okay. I was not done. But it said grayscale. I can't help but wonder if what it really wants me to do is grayscale it. But again, we're just seeing the one disparity map. So maybe it's just about reversing the images. I mean, it might be as simple as that. And then is what returned. It's a disparity map. Goes back to the fact that I'm not debugging. It really bothers me that I'm not debugging. You know what? I can debug though. Like, break it out. Break out PyCharm. What are we calling this? Dense reconstruction? The only thing I need, theoretically, is the imports. Why are you whining? Oh, I don't need you. Oh, I should probably get the base path too. This. Acting as if I don't have CV2 import. Oh crap, I do. Base path. Sure. So our sample is 2 equal. Path 1 is path 2 is gonna be go to. I can look at the drive. Art room 1. And in art room 1, go away please. I am 0 and I am. What block size? It doesn't provide a block size in the file. Gemini's example had the number of disparities much lower and a block size of 15. I'm afraid to do 15, but let's do 15. The worst thing. Then go ahead and do this the easy way. Plot dot imshow, excuse me. No, hold up. We're not doing main. We are doing dense reconstruction. Yay. No attribute. It's called join. See, this is why, like, this is why I need the debugger. This is exactly why I need a debugger. collab might be giving me this information, but it's not. It probably wouldn't give me line level information. And look at this, and the in process values that we have, right? The problem here that the AI forgot to deal with was the whatchamacallit, the brackets. So sure, we split on that. But I have to trim it somehow. Sure. In fact, I'm gonna just take this whole thing. Surprised there's not something more useful in Python, to be fair. I'm gonna stick this as a helper method. Import regular expressions. The regular expressions tend to be slow. I think what I want to do. Actually, I just realized that this whole thing is wrong. This, the for loop we don't want or need. You split on that to get you your 3. And then you split on, I guess, space. Give you your 1. Can I do a sub on, like, on an array rather than a string? Think it'll let me do that? Give it a shot. See what happens. We're not so tightly typed as C#. Maybe it will do magic. Yep. That did not work at all. But. Bam. Look at how smart I am. Oh, didn't work. What are you complaining about now? Expected string or byte-like object? For string in R, 3.sub string. Like, that's right. Okay. There's another way we can do this. So we know this object here actually typo. Fixing AI code is a pain in the butt sometimes. MP array this an extra print. There we go. Okay. So if we substring and leave out the first and the last character, that would give us our answer. So it would be like dot substring. I mean, a little crude, but I think that's gonna serve the needs without overcomplicating it. Sure, there's a fancier way to do that. Don't need you anymore. One of the argument's values is out of range. SAD window size must be odd, be within 5 and 255, and not be larger than the image width or height. Is that because 170 is not odd? Well, why does that exist in the first place then? And now it's gone. See, that's even. Why are we in a problem? Image left and image right are none. You know why that is? It's because it's not a freaking PNG. Yes, it is. Oh my. I am 0.png. I am 1.png. Hey. Less. Grumble, grumble, grumble. It's right here. This is what debuggers are for. It's too late. I'm so tired. Well, at least left and right are exist. The important part. Unsupported format or formats. Honestly, that's a pretty easy thing. I'm gonna go ahead and move it to grayscale. What is it called? Vert color or something like that. Put over here, I thought. Apparently I don't do it over here. What is it called, man? There it is. It was there. Probably RGB to gray. Okay, oh. Really a stickler for these things. That's unfortunate. Alright, so that worked. In fact, that worked exactly how I wanted it. 1x2 for now. 1x2 or 2x1? It's 1x2. Ugh. Can't remember these things. Gonna have one row with 2 columns for now. Although, actually, what I should be doing is comparing it to the other one. We'll see. Deal with that later. So, axis. So, this time I'm gonna do disparity 2 and just swap them and see if that is what we're wanting to do. Good song. Why do you hate? Must be divisible by 16. So clearly whatever this is, it's not what we think it is. Alright, divisible by 16. Pretty easy. We could probably do 128. A block size too large, maybe? Although that is proof of concept. That is effectively what we were looking at. What's my block size? Too small or too large? Should a block size have to be odd? Probably. I don't know what the difference this is going to make is. Is a larger block size better? Oh yeah, that's not good. So let's go down. We'll go down to 5. We're gonna try to make it as close to the examples. That's almost exact. Kind of nuts, actually. Okay. Okay. We're golden. That's good. That is fantastic. Finally making progress on this homework. I'm gonna be up late. We got our disparity, and we understand how to get both disparities. That's done. That's happy. Compute the point cloud using the left image, left disparity, and the given calibration parameters. Save it as a PLY. Alright, well, okay, so I think this is a good place to resync here. In fact, what I'm going to do is... Actually... So... That's wrong. Make sure this still builds. Okay, chill. You. This is such a good song, I want to call out the artist. This is... Oh, I can't see. Rosin. That's right. Rosin. He does a lot of fantastic arrangements of different video game music, in particular some Zelda music. And so it's just really good. So here's a call out to Rosin. I would highly recommend checking out some of his stuff. I use YouTube Music. You can do whatever. Rozen. Anyways, moving on. We're doing a whole bunch of copy pastes. You know, that was probably my mistake with this section before this, was I was relying so much on not, like, I didn't do any debugging before I got stuck. So there was no proof of concept for anything that I did. I'm not going to run this particular code. Because I want to make sure that I want to keep these. I want to know what I'm doing, basically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I see 10. So we will go ahead and do 10 rows for 2 columns. All right, we need the original left. 1, 2. It's wrong here, but that's fine. It makes it a little quicker. I actually have to load the files, but I don't know if load image will work on a PFM. So it wants me to just fine. I was hoping not to add an import, but whatever, we'll do it. Oi! It's not gonna let me. And I doubt it's gonna let me pip install either. Console is for paid only. If I could load it like an image, that's fine. As mentioned earlier, that's really really underhanded. Just throwing that out there. As mentioned earlier, the recommended way to load PFM files is Python is to use the pipfm library, which Google Colab apparently does not support, unless I typoed it. Of course. I cannot even... It's not a recognizable file form. I mean, if I do a PNG like that, same thing. What if I tried? What would be the worst case scenario here if I tried to load a PFM file? It's things like this that really get me though. Like, wait, it worked? Guess we'll find out. It worked. Sort of. Oh, go away. Also, let's stick it with... That seems less than ideal. Okay, let's try this. Hold up. Avast, really? You're gonna bug me about this right now? Go away. It's grayscale. 1080 1920. I'm a little shocked, honestly, that it loaded. Alright, so I'm going to do something that I've done before. I don't want to waste a whole bunch of time trying to get that to display correctly. The code compiles, it displays. This is supposed to be the ground truth. I don't really care if it's accurate or if it looks accurate in this display. I just don't care. I'm going to try one more thing. And I'm going to convert it to grayscale. Although it already is, so what do I do? Gray to gray? Like... what options do I have? Yeah, it just doesn't work. So yeah, I'm not gonna have a heart attack over this. Google Colab does not support PFM, so I loaded it the only way I know how. And if I lose points for it, so be it. I can't pip install on Colab, and Colab, or at least the notebook, is the file type that he wants me to use. So that's what we're doing. Okay, so covers the first 3. Now I need to do part 2. Did I already read it? I didn't. Is this? Did I type it in here? I didn't. Okay. All right. Keep going. It's late. I don't care. We gotta get going. Gotta compute the point cloud. Here's to hoping that AI decides to make my life easier. It wants me to get the point cloud for left. Are we doing that also for the right? No, I think... And I think that matches what I saw too. After the disparity comparisons, we basically just use... words thinking fun time. Basically just use the left image. So... Just let AI do it. Little cheating, but I think as we've seen up here, AI isn't always what it's cracked up to be. I have to check its work. The reproject image to 3D, that is what this is. So that's what we wanted. Left. Why would we change it from BGR to RGB? It's already RGB, isn't it? Create the mask. The min and max, which is passed in. These are all things I'm actually familiar with. I have a personal project that converts 2D images and videos to 3D, stereoscopic 3D. And I have done a lot of image visualization with this. So a lot of these mask operations are pretty familiar with me, including HStack. Output points and output... Why are we... Not entirely sure why we're HStacking this. This makes sense. Or does it? Because you're overriding it here. So really what this should be is... we have our disparity here, so we'll take everything that's greater than the Vmin, which will include things that are greater than the Vmax. And then we've got to tame it here. So that was a mistake. I don't know how I feel about this. I think I'm gonna have to debug this one. I need to know what's going on. Comments too for copy paste sake. We have our disparities. We're going to do hopefully image one line as a color image. And one is never. Is that okay? At trying to get on my keyboard. Handle missing values is not convertible to bool. Figure out what this does. Disparity mapping Q. Obtained from stereo calibration. What is it called when you have the same method but different parameters? I want to say overloads. Alright, it's not going to be helpful to me, so we're going to have to go to patient. So the input array could just be disparity? Oh, input. I really dislike this method of documentation. So I don't have Q. So I have to calculate Q first? Is that how this is gonna go? And how do I calculate Q? Obviously, disparity's there. That's not a problem. Vmin and Vmax are used. What is D offset? Zero. Pain from separation. Given you're gonna make me use camera calibration. Stereo rectify. Look, that is in fact one of our functions. So let's do stereo rectify. This is coefficient. Let's stereo. I don't have distortion coefficients. Please don't make me go back. Well, I'm screwed. Because stereo rectification, look at the Q matrix, relies on the work that I was stuck on. How appropriate of a song. Wait. The stereo rectification uncalibrated. The only way I'm gonna get Q is through stereo rectification, not uncalibrated. I need to get the intrinsic matrix, which brings me back to my catch-22 that I was in. So I can't do this without finishing the first part. I can't do this second part. That's where I'm getting stuck. This is easy, but I'm stuck there. I really hope this second section didn't rely on the first. I really wanted it to go well. All right. The homework is due at midnight tomorrow. I have class, hopefully with my professor. He was talking about how he might not be in class some days here at the end of the semester. So if he's not in class, well, I'm screwed. So I need to rewatch the lecture where he explains this. And I'm going to ask questions on this. And hopefully I can get some decent answers. Because I'm blocked. And I'm confused. Without the intrinsic matrix. Not the intrinsic, excuse me. Yeah. It's a catch-22. And I don't understand how to fix it. Although I can keep going. Maybe. I don't need to know the meat of the method, just the return. I don't know. I feel like that would be too difficult to figure out. All right, so here's what I'm gonna do. I'm gonna go ahead and call it a night. And what's going to happen is I'm gonna get past this blocker, and I will reconvene. I will try to reconvene the stream. I have a family. People want attention, want to spend time with me, which is awesome. So hopefully I'll reconvene on the stream tomorrow, and we'll get the glorious conclusion to this extremely painful assignment. Once we finish this, once we do these last 4 images, basically, last 2 steps, it's copy-paste the rest of the way for the second half. Copy-paste. And then up here, once we have our matrices, which, because of the catch-22, we only have the fundamental matrix. I'm hoping sparse reconstruction output will be quick. Why are we throwing... Yeah, it's labeled as 5 points. It's probably really easy. This extremely confusing explanation of a text, combined with the fact that in order to do triangulation, I need projection matrices. I'm stuck right here. These what, 20, 30 points? Yeah, even that's confusing. Ten plus 10, 30, 45, 50, 60, 75. Not 75. 5 points. Then 20, 30, 45, 5, 65, 35, okay, 80. There it is. So yeah, these 30 points is stopping me from finishing the homework tonight. Even the second section. And I'm not sure what I can do about that. So it's late. I'm exhausted. So I'm gonna call it here. And I hope y'all enjoyed the soothing tones of my voice, Zelda music, and looking at code, which is super exciting. But I wanted to be a little more present on the streams, and I'm thinking, try to do some homework. Anyways, hope y'all have a great night, and I hope to see you tomorrow for the exciting conclusion of stereo rectification and reconstruction. Thank you very much.